Okay, so today we are diving deep into swarm robotics.
Sounds fun.
You know those sci-fi movies with robots taking over?
Yeah,
It's kind of like that, but instead of one big baddie, it's all about teamwork.
I like teamwork.
We've got a stack of research papers here about it, even some cool stuff about how this tech is helping design things like air pollution control systems.
Robots cleaning up our mess.
It's wild.
I know, right?
And to help us break it all down, we've got expert speaker with us. So, are you ready to swarm our brains with knowledge?
Absolutely. What's so fascinating about swarm robotics is that it takes inspiration from nature to solve problems.
Okay, so before we get ahead of ourselves, let's start with the basics. What exactly is swarm robotics?
So think of ants or bees, how they work together in groups, no boss needed.
Right.
Swarm robotics is similar. You've got a bunch of robots, each pretty simple on its own, but they follow basic rules, they react to each other and their surroundings.
So it's less about one super smart robot and more about the power of many. But why is that such a big deal? Why is that so important?
Well, traditional robots, they're great at specific tasks,
Sure.
but they're not very adaptable.
Yeah.
Swarm robots can tackle unpredictable situations as a team.
Okay.
So imagine like a collapsed building after an earthquake.
Oh, right.
A swarm of robots could quickly cover more ground, searching for survivors in places humans can't reach.
That's incredible. So search and rescue is one application, but what else can these swarms do?
Oh, the possibilities are huge. Imagine a swarm of robots working together to move a heavy object, like ants carrying food many times their size.
Wow.
This could revolutionize construction or even be used to transport supplies in disaster zones.
Okay, now that's just cool. It's like having a team of tiny construction workers, only way more efficient.
Yeah.
Are there any other applications that really highlight this teamwork aspect?
Definitely. Think about environmental monitoring. We could have swarms of robots monitoring pollution levels in our oceans or tracking the spread of wildfires in real time.
Oh,
They could even coordinate to contain a fire.
really?
The data they gather could be incredibly valuable for protecting our planet.
This all sounds amazing, but I imagine there must be some serious challenges in getting these swarms to work together seamlessly. What are some of the biggest hurdles?
You're right, it's not all smooth sailing. One of the toughest challenges is communication.
Of course, yeah.
How do you make sure all these robots can effectively talk to each other without a central command?
Right.
It's like trying to have a group conversation in a crowded room with everyone talking at
I
once.
can only imagine.
Yeah.
What other challenges do engineers face in designing these swarms?
Another major obstacle is the hardware itself.
Okay.
Building robots, especially tiny ones that are both affordable and capable, is a huge engineering challenge.
Right.
You need to think about battery life, processing power, and all the sensors they need to navigate their environment.
So it sounds like creating the brains behind these swarms is kind of a critical piece of the puzzle. That's where computer engineering comes in, right?
Absolutely. Computer engineers are essential in designing the algorithms that allow these robots to interact, learn, and adapt as a group. Think of it like this. They're developing the language and the social skills these robots need to function effectively as a team.
Okay, so they're not just programming individual robots, they're programming a whole society of robots. So they're not just programming individual robots, they're programming a whole society of robots.
It's even more complex than that.
Okay.
It's not just about social skills. It's about creating a system where these robots can learn from each other and their environment. It's like teaching them to improvise a perfectly coordinated dance, even when the music changes unexpectedly.
So it's like they're constantly learning and adapting their routine as they go.
Yeah.
That's mind-blowing. What kind of computer engineering magic makes that possible?
Well, a lot of it comes down to algorithms.
Correct.
There are different types, each with its own strengths. For example, you have evolutionary algorithms, which are inspired by natural selection. So they test different strategies and keep refining the ones that work best, just like evolution itself.
So it's like survival of the fittest, but for robot code.
Exactly. And then you have ant colony optimization algorithms,
Okay.
which are inspired by, well, ants.
Makes sense.
They leave behind these digital pheromone trails that guide other robots, just like ants use pheromones to find like the shortest path to food.
That's so cool. It's amazing how nature provides such elegant solutions to complex problems.
Absolutely. But designing these algorithms is only half the battle.
Right.
You also need to develop communication protocols that allow these robots to share information quickly and reliably, even in chaotic environments.
Right, because a swarm that can't communicate effectively is about as useful as a group project where nobody talks to each other.
Exactly.
So what are some of the communication strategies used in swarm robotics?
One common approach is to use local communication,
Okay.
where robots only talk to their immediate neighbors. It's like passing a message along a chain. This method is very robust because even if one robot malfunctions, the message can still get through.
So it's like a game of telephone, but with higher stakes.
Exactly. But for more complex tasks, sometimes you need a combination of local and global communication.
Right.
That's where like a central control system comes in.
Okay.
Kind of like an air traffic controller directing a flock of birds.
Gotcha.
Yeah.
Okay, so we've got these brilliant computer engineers working their magic, but let's get back to the real-world impact. We talked about search and rescue, construction, and environmental monitoring. What are some other fields where swarm robotics is making waves?
One really exciting area is medical robotics. Imagine swarms of tiny robots navigating your bloodstream, delivering targeted drug therapies, or even performing minimally invasive surgeries.
Whoa, robots operating inside the human body. That sounds straight out of a sci-fi movie. What kind of technical challenges are involved in making that a reality?
Well, for starters, these robots need to be incredibly small and maneuverable to navigate the intricate pathways of the human body. We're talking about robots on the scale of a few micrometers,
Wow.
which is smaller than the width of a human hair.
Wow, that's tiny.
Yeah.
I can only imagine the precision required to design and build something like that.
It's incredibly challenging. They need to be biocompatible so they don't, trigger an immune response. And they need to be able to move efficiently through fluids that are much more viscous than air.
It sounds like there's still a lot of hurdles to overcome before we have swarms of nanobots swimming through our veins.
Right.
What are some of the specific challenges in developing these medical microrobots?
One major challenge is powering them.
Right.
You can't exactly stick a battery on something that small.
Yeah.
So researchers are exploring things like using external magnetic fields to wirelessly power and control them. Another challenge is navigation.
Okay.
How do you get these tiny robots to their target destination inside the body without getting lost?
It's like trying to navigate a maze, but on a microscopic scale.
Precisely. So scientists are looking at ways to use medical imaging like MRI or ultrasound to create real-time maps that these microrobots can use to find their way.
It's incredible to think that we might one day have these tiny robotic explorers navigating our bodies,
Yeah.
fighting diseases at the cellular level. That
That's
sounds like something straight out of science fiction.
It really does, doesn't it? And that's the beauty of swarm robotics, It's constantly pushing the boundaries of what we thought was possible. It's not just about building better robots. It's about reimagining what robots can do and how they can interact with the world.
So where do we go from here? What's next for swarm robotics? What are some of the big unanswered questions or challenges that still need to be tackled?
Well, one of the most exciting areas of research is in developing even more sophisticated algorithms that allow swarms to exhibit truly emergent behavior.
Emergent behavior, what does that mean?
So it means that the swarm as a whole can achieve complex goals, goals that go beyond the capabilities of any individual robot.
Okay.
Imagine a swarm of robots that could like spontaneously self-organize to build a structure like a bridge or a shelter without any pre-programmed instructions.
That's wild. So it's like they're improvising based on the situation and each other's actions.
Exactly. This kind of emergent behavior is found everywhere in nature, flocks of birds, schools of fish.
Right.
But replicating it in robots is a huge challenge. It requires a deep understanding of how individual behaviors can lead to complex collective outcomes.
It sounds like there's still a lot we can learn from nature when it comes to designing these swarms.
Absolutely. And that's why swarm robotics is such an exciting field. It's a constant dialogue between biology, computer science, engineering.
Yeah.
By studying how swarms operate in nature, we can gain insights into how to design more robust, adaptable, intelligent robotic systems.
So it's not just about building robots that can mimic nature. It's about understanding the fundamental principles of swarm intelligence and applying them to create something totally new.
Precisely. And the potential applications are truly transformative. Imagine swarms of robots working together to clean up pollution, monitor ecosystems, or even explore other planets.
It's like we're on the cusp of a new era of robotics, one where robots are no longer just tools, but collaborators working alongside humans to solve, some of the world's biggest challenges.
I couldn't have said it better myself. It's an exciting time to be working in this field. There's a real sense that we're only just scratching the surface of what's possible.
Well, I don't know about you, but my mind is officially swarmed. Expert speaker, thank you so much for taking us on this deep dive into the world of swarm robotics. It's been an incredible journey.
My pleasure. I always enjoy talking about the incredible potential of swarm robotics.
And to our listeners, we hope this deep dive has inspired you to learn more about this fascinating field. It's a field that's sure to shape the future in ways we can only imagine. Until next time, keep those minds buzzing. And remember, sometimes the best way to solve a big problem is to think small, really, really small.